the wiring of these systems. They start from the DRG, they go to the spinal cord, different locations in the spinal cord, then they reach the brain, they end in different areas of the brain, right? They finally go to the cortex. Somatosensory area 1, 2, and yeah, association of areas, right? So now let me talk more about these connections between the thalamus and cortex, right? And then we get back to the function of this wiring. So this is the thalamus, right? I told you. In the thalamus we have several nuclei. Some nuclei are related to vision. We have mentioned that. Some nuclei are related to hearing. I didn't talk about that, right? Some other nuclei are related for example, for taste. Okay? So for every type of sensation we have, we may have different nuclei. But for somatosensory sensation, right? We have ventral posterior nucleus. So imagine that this is the ventral posterior nucleus in the thalamus. So one nucleus in the thalamus, right? So I told you that it has two parts. Lateral part, medial part, right? Now, let me actually refine my words. So, ventral, posterior, lateral, ventral, posterior, medial, but we have also ventral, posterior, inferior, ventral, posterior, superior. So, here we have the cortex, right? Central sulcus, so it's a fissure. So, we have this fissure, right? So, it starts from Brodmann area 3, Brodmann area 3A, right? 3B, so both of them are part of the somatosensory area 1, Brodmann area 1, Brodmann area 2. So these areas are somatosensory area 1. And I told you that we have Brodmann area 5 and 7, right? And we have also somatosensory area 2, right? So somatosensory area 1, somatosensory area 2, somatosensory association. So now let's see the connections. So fibers from the face go to ventral posterior medial. Fibers from the hand, foot, and the body, right? Go to ventral posterior lateral. So these fibers are in orange, right? So you can see the orange one is related to fine touch and vibration, right? So information about touch, vibration, and also pressure go to ventral posterior lateral, and from the body to the lateral one, from the face to medial. So this one is in green, so it's related to pain and temperature, right? So they go to ventral posterior inferior. This one, the red one, is related to position sensation, proprioception, right? So position receptors are in muscles, in joints, and in bones, right? So we have muscle spindles, Golgi tendon organs, so I didn't talk about that. I only mentioned 6 receptors related to touch, pressure, and vibration, right? So we have other receptors related to position, right? They are in muscles and bones and joints, right? So from these receptors, information go to ventral posterior superior, right? Now let's see how fibers from these areas go to the cortex, right? So ventral posterior lateral and medial, sending information to Brodmann area 1 and 3B. So touch, pressure, and vibration go to these areas, these two, right? What about position sensation? Yeah, they go to ventral posterior superior. Then from here they go to 3A and right? So what about pain and temperature? They go to several regions. Some of them go to somatosensory area 2, others go to insular cortex. I will talk about this later in the next session, right? But now, you can see that position sensation and touch sensation finally go to Broadband area 5 and 7. So they merge together where? In Broadband area 5 and 7. So we can say that touch, pressure, vibration go to area 3B and 1. Position sensation go to 3A and 2. So they are analyzed here in this part. Then the result is combined together where? In somatosensory association of areas. Broadband area 5 and 7. So initial processing, the start of the processing happens in Broadband area 1, 2, and 3. But final processing happens in Broadband area 5 and 7. Initial processing is related to basic elements of the touch. Basic elements include, so for example, you want to touch this, right? So you touch this and you can feel it. You can feel what? So the borders, texture and pattern, temperature, weight, right? What else? Yeah, maybe, shape is something different. Okay, so basic elements are these: borders and edges, pattern, and maybe it has a vibration. Okay, so this is also basic element. So these are basic elements and they are analyzed in somatosensory area 1, Broadband area 1, 2, and 3, right? Then combination or the result of this processing goes to Broadband area 5 and 7 association area, which is located higher than the first one, right? So in this area, all of these basic elements are combined together and we can feel shape. We can feel form of the object. And finally, in Broadband area 5 and 7, we can understand the name of the object. Okay, so we can recognize the object. So we can say that when we feel something, it has two parts. Processing has two parts. Basic processing, final processing. Basic processing happens in somatosensory area 1. Final processing happens in somatosensory association areas. Basic elements include edges, pattern and texture, vibration, pressure, weight of the object, right? But final processing includes shape, form, and name. So finally we can recognize, oh, this is a marker. This is an eraser, for example, right? So we can understand the object. Okay, now based on this, if there is any damage to the cortex, right? So if we remove somatosensory area 1, what happens? So basic processing doesn't happen, right? So what happens? Vibration is lost. We cannot understand vibration if there is any in the object. Proprioception is lost. Remember, Broadband area 2 and 3A was related to position, proprioception. Now they are all removed, right? So proprioception is lost. Fine touch. Which areas? 3D and 1. Remember that? So they are removed, right? Fine touch is also lost. What else? Localization is lost based on the activation of neurons in somatosensory area 1. Remember, we have a map of the body. Toes are represented medially, right? Face is represented laterally. So we have a map of the body. Now imagine that this map is removed, right? So maybe we have touch in the body, signals go to the brain, but there is no target for these fibers. So the final area is removed, right? So we don't know the localization of the touch. What else? Judgment about the degree of pressure and weights of objects and texture of the materials are all lost. So this loss is represented clinically in some symptoms or some signs. So if you consider the patient, if you want to examine the patient, right? So after removal of the somatosensory area 1, the patient will have agraphaphysia. So this language is related to physiology. This language is related to clinical problems, right? So when we talk about physiology, we say that vibration is lost, texture is lost, I don't know, touch is lost. But in clinical terms, we don't use these words. In clinical terms, we say the patient has agraphaphysia, the patient has astereognosis, the patient has hemihyperplasia, right? So these are clinical terms. So agraphaphysia means you write something in the hand, the patient cannot understand it. So if you close your eyes and I write letter A, you can understand it, okay? Usually I play with my kid, with my daughter, like this. I write something in the hand and she tell me what I've written, right? So the patient cannot understand this. If you write anything in the palm, right? So we call this agraphaphysia. Astereognosia, impaired judgment about the shape of forms or objects. You maybe put this in the hand of the patient without somatosensory area 1. The patient touch this, they don't know what is it. Okay? They can feel something in the hand, but they don't know what is the object. Okay? So we call this astereognosia. Hemihyperplasia. So the general level of touch in the skin is reduced. Right? So loss of touch, loss of vibration, loss of pressure. Hemihyperplasia. Why hemi? Because I told you, the right hand is connected to the left hand is connected to the right brain, right hand is connected to the left brain. If there is damage only on one side of the brain, reduction of the touch happens on the opposite side, not on the same side, right? So that's why we call this hemihyperplasia, right? So from these features, these two, or let's say this one is something related to basic elements, right? But this one, inability to recognize letters, inability to recognize objects, it's related to final processing that happens in Brodmann area 5 and 7. Why? This patient has a problem in somatosensory area 1, no problem in Brodmann area 5 and 7. Why this patient has this astereognosia or agraphaphysia? Okay? So the reason is here. I told you. Information first go to somatosensory area 1, then from here they go to somatosensory association area. So when you remove this area, the functions of this area are lost. The functions of this area is also lost because they need information from this area. Right? Got this? But now you can imagine a patient with intact somatosensory area 1, but with removed somatosensory association area. What happens? So you can expect that the patient can understand basic elements of the touch, but cannot understand higher level elements like the form, shape, and name. Right? So, sorry, let's see this one again. The effect of removing somatosensory associational area is problem understanding complex objects felt in the opposite side, on the opposite side of the body. So the patient is not able to understand the complex shape of the object. The patient can feel the touch, can feel the edges, the borders, vibration, anything in the object, but cannot combine together and reach the final conclusion about the name of this object. Right? So again, if the patient shows a stereognosis, inability to understand object, the shape of the object. But at the same time, the patient has other problems also. Remember that some of the information that is processed in the somatosensory associational area is related to position sensation, right? Some of them are related to touch, others are related to position, so they are different actually, right? So here in Brodmann area 5 and 7, we are able to understand the location and position of any part of our body. So you can close your eyes and tell where your arms are looking, how they have position, if they are bent or they are stretched, if you put your knees over leg or not. Okay? So you know exact position of your body parts. Why? Because information from joints and muscles go to the brain, Brodmann area 3A and 2. Then from here they go to Brodmann area 5 and 7. Here you know the shape of the body, position of the body, posture of the body, position of the parts of the body. Right? Now, if there is damage here, the patient is not able to understand the position. Right? So we say that proprioceptive information is lost. Proprioceptive processing is lost. So, damage is on the right side, right? Information from the left side of the body are not processed. So the patient doesn't have any image, any internal image of the left side of the body, right? When the patient thinks about his body, he can understand the left side, the right side. But he doesn't have any idea about the left side. Why? Because Brodmann area 5 and 7 on the right side is removed. Right? So we call this condition amorphosynthesis. Amorphosynthesis. The patient is not aware of the left side of the body and the left side of any objects, left side of environment, left side of things that they can see. Okay? So we call this hemispatial neglect. Actually, I will talk about this later for you. Okay? But for now, you should remember this. Brodmann area 5 and 7 is responsible for final processing of touch and position. If it's lost, the patient is not able to understand objects by touch. We call this astereognosis. Right? But there is also problem understanding position of the body or proprioception. Because the damage is in the right side, the patient is not able to understand the left side of the body. Right? So the patient is not also able to understand the left side of visual scene. Okay, when we see something, when we see a scene, right, the left side is ignored. The patient only attend to the right side. Okay? Generally we call this amorphosynthesis. Okay, got this? How much time left? Yeah, 20 minutes. Okay, now let me talk about let's ignore this. Okay? So let's ignore these parts. For that, do you have practical physiology also? Yes? Did you have 2-point discrimination?
Is it the one with one finger with the thumb?
Yeah. So you have this. Okay, so you know the physiological basis of the, let's say, 2-point discrimination. Okay, ignore this, and instead of this, I will start. Actually, I want to start with the next topic, but we finish very soon. Okay? After 10 minutes, we will go. We are talking about somatic sensations. We started with touch, pressure, vibration. Now, in this session or in this part, we will continue with pain and temperature, two other type of somatic sensations, right? Pain and temperature. So pain is an unpleasant feeling, unpleasant sensory and emotional experience that happens after actual or potential tissue damage. So, any tissue damage that happens in the body causes an unwanted feeling, which is called pain. But remember, it's a protective mechanism. It's good for us, right? So pain is a protective mechanism because it's a signal we cannot ignore, right? So you can ignore touch, you can ignore pressure, but you cannot ignore pain. So imagine that you have toothache, right? And it gets worse and worse. So you cannot ignore it. You should actually seek for some medication. You should go to the dentist. So this way you can remove the reason for tissue damage, right? So it's in favor of our survival. So it causes the individual to react to remove the pain stimulus. So people that are congenitally insensitive to pain are easily injured, right? Because of this injury, they cannot feel pain, right? And this injury continues and gets worse, right? And these people usually die sooner. So again, pain is very good for us. Actually, some type of pain are not good. Sometimes you may have chronic pain. You cannot do anything for that. So it's only suffering. It's not okay. Right? So it's better to say that some types of pain are protected, others are not protected. Others are only something suffering for us. Right? So, okay, we have two types of pain. Pain, fast pain and slow pain. Fast pain is felt within 0.1 seconds or less than 1 second. But the slow pain begins after 1 second and increases slowly. Right? So fast pain, slow pain. So this is a physiological definition. This is a physiological classification of the pain. Usually in clinics we don't use this fast pain, slow. Okay? So in physiology, because we focus on physiological basis, we divide pains into fast pain, slow pain. So other names for fast pain include sharp pain, pricking pain, acute pain, electric pain. So all of them are fast pain. Types of slow pain include burning pain, aching pain, throbbing, throbbing? Yeah, like beating. So throbbing pain, nauseous pain, so pain accompanied with nausea, right? And chronic pain. So all of them refer to slow pain. So fast pain is usually felt in superficial tissues, not in deep tissues. But slow pain can be associated with tissue damage both in skin, superficial, and deeper tissues, right? So this type of pain is prolonged and cause unbearable suffering. Okay. Now let me talk about receptors, right? So remember that for touch, pressure, vibration, we have 6 receptors, right? Here, for pain, we have nociceptors. Nociceptors are only free nerve endings. So we have some free nerve endings that are related to touch, pressure, vibration. We have seen them before. But other free nerve endings that are related to pain. So we call them nociceptors. So free nerve endings are abundant in superficial layers of the skin and in some other tissues like preosteum. What is it? Preosteum? No. Preosteum. Yeah, in the bone. Yeah. So the cover or the layers that cover the bone is called preosteum. So in the preosteum we have a lot of free nerve endings that are nociceptors, right? So arterial ones, again, it has high density of nociceptors. Joint surface, again. Falx and tentorial, what are these? Falx and tentorial, and cranial bones. The covering of the brain that goes inside the longitudinal fissure is called falx. And the layers that go in the fissure between the cerebrum and cerebellum is called tentorial. So again, in these tissues we have a lot of nociceptors. So that's why any damage here is very painful. Right? Any damage to the bone is very painful. Damage to the arteries is very painful because we have a lot of nociceptors. But in other tissues, we have only a few of the nociceptors. Right? So, for example, in the liver, in the brain, in the lung, we don't have so much nociceptors. So usually we don't feel pain, for example, from liver, or from the lung, or from the brain. Right? But in the brain, we have a lot of vessels, and we have falx and tentorial. If the damage spreads to these areas, it's painful. Right? So pain receptors are non-adaptive. Non-adaptation means reduction in the firing rate if you have constant stimulation, I told you, right? So now, you may have a wound in the skin, so the stimulation is constant, but pain increases slowly. So instead of decreasing the firing, we have increase in the firing. So so generally, is that rapidly adapting or slowly adapting? Slowly. Do we have adaptation? Sometimes no. Right? Instead of adaptation, we have sensitization. We call this hyperalgesia. Okay? So pain receptors are maybe non-adaptive. Right? So in the next session, I will continue from the definition of hyperalgesia. Okay?